Hey everyone, in this video we're going to build a quest log where we have a scrolling list of quests, and when one of those quests is selected, we'll display details for it, including the requirements for starting the quest, the rewards for completing the quest, and some text to indicate the current status that will automatically change as we progress through the quest. And we'll even do some fancier things like crossing out the quest steps as we complete them and coloring the buttons in this scrolling list based on the progress state for each quest. And as always, the entire project, including the starting point and everything that we're going to do in this video, is available on GitHub, which is linked in this video's description. And one last thing to mention before we get started is that we will be starting with an existing project that has a quest management system that was built in a previous video. So just as a quick disclaimer, there will be quite a few things in this video that are specific to the existing quest management system. However, with that said, we'll be creating the UI mostly separate from the existing system, aside from the actual integration of it. So if you're just looking for general information or having trouble building out the UI for your own quest log, my hopes are that this video will still be helpful to you even without having seen the previous one. And if at any point you do feel like you need more context on the project we're starting with, I realize the previous video is quite long, so to save you some time, you can likely gather all of the context you'd need by watching the video up through the project overview timestamp. And with that out of the way, let's talk about how we're going to build this quest log. And a good starting point for that, or really for building any user interface, can be looking at what we want to create and then breaking that down into smaller pieces, since that will help us keep focused on the little parts we need to build to create the larger UI. For the quest log UI, the final result is going to look like this, so let's break this down. First, we have this scrolling list on the left that contains all of our different quests, which will certainly be its own piece that we need to build, and for that we'll use a scroll view, which is a built-in Unity component. However, there are several custom modifications that we'll have to make to get it to work like we want it to, and so we'll call this piece the quest log scrolling list. And then within that, we have a bunch of buttons that can be used to select each quest, each of which will leverage the Unity built-in button component, but will also contain some custom code for things like handling what happens when a button is selected and setting the progress state color. So we'll consider this its own piece of the UI and call it a quest log button. Then on the right hand side, it's quite a bit easier because all of these pieces will simply be TextMesh Pro text objects. And so that pretty much does it for all of these smaller individual pieces. So next, to tie all of those pieces together, we'll create a script called quest log UI. For context, the quest system we're using sends out a Unity event called quest state change anytime a quest changes, which includes when the game first starts up and that quest gets initialized within the quest management system. And that event passes along the quest object for the quest that changed, which is a custom data structure that contains all of the relevant information that we'd want to display in our quest log. So our quest log UI script can simply subscribe to that event, and then when the game starts up, it'll receive a quest state change event for each quest in the game, which we can use to initialize all of the buttons in the quest log scrolling list. And as for how we'll link together the left and right sides of this quest log UI, when we initialize one of the quest log buttons, we'll pass through a Unity action, which if you're not familiar is just a function that we can call back to whenever appropriate. And then when that quest log button is selected, we'll call that Unity action, which will set all of the appropriate information on the right hand side for that quest. And because objects in C# are passed by reference, we only have to set this up once during the initialization for each of the quest log buttons, and then that Unity action will always reference the most up-to-date quest object when setting that information. Then for changing things like the color of the button, because of the pass by reference thing that I had just mentioned, we could handle that completely internally within the button. However, to be a bit more direct, since the quest log UI will already be receiving quest state change events, we can create something like a set state method for the quest log button, which changes the button's color depending on the incoming progress state, and then call that method from the quest log UI anytime we receive a quest state change event. And last, as for the status text, our quest management system already has a nice structure to support this, but we'll have to make a couple of small modifications. I'll go into detail on that later in this video, but once that's done, it's just a matter of formatting that status however we'd like. So for example, having strike-throughs for completed quest steps, or even additional text depending on the overall quest state. And that's how this is all going to work. So finally, let's jump into implementing all of this, starting with creating the quest log button piece of the UI, which as a reminder is each of these individual buttons that when selected display information about that quest in the quest log. In the scene hierarchy under the canvas, we'll right click and go to UI and then button TextMesh Pro, and then we'll rename that to quest log button. And then we'll give this a top center anchor, and we'll make it have a width of 275 and a height of 30. Then we can style this however we want. I'm just going to make the normal and selected colors a bit darker with different opacities. And we'll also change the text color to make it stand out a bit more. Next, under the scripts UI folder of the project, we'll create a new C# script called quest log button and then double click it to open it up. As mentioned previously, we're going to pass through a Unity action to be called when this button is selected, so let's set that up. First, we'll add a using statement statement for UnityEngine.events and another for UnityEngine.eventSystems. And then we'll implement an interface called iSelectHandler, which will give us this method called onSelect, which automatically will be called when this game object has been selected by the event system. And from there, we can create a private Unity action called onSelectAction and then call that when the onSelect method fires off. Next, the plan is that the quest log scrolling list is going to instantiate this quest log button later on, but with how things will be set up, the button itself will actually be disabled when this happens, which means we can't use the start or awake methods of the Unity lifecycle to initialize like we might do with most mono behaviors. So instead, we'll do the initialization in a method called initialize that we'll call manually once we've instantiated the button. And when doing so, we'll pass along the appropriate Unity action for this button and set that to our onSelect action. And we'll also want to make sure the button's text gets set to the display name for this quest, so we'll add a using statement for tmpro, and then create a private field for the button text, initialize that in the initialize method, and then pass in and set the display name to that button text. And that's good for now, so back in Unity, we'll add this script to the questlog button game object that we created, and then we'll drag this into the prefabs folder of the project to make it a prefab. And I'm also going to zero out its positional values as a best practice, and then we can delete the game object from the scene hierarchy. Next, we'll create the scrolling list component that's going to use that button prefab. First, under the canvas game object, we'll create a new scroll view by going to UI scroll view, and then we'll call it questlog scrolling list. Then we'll change the size to be a bit bigger. I'll make it 275 by 360, and just to note, I'm picking a width of 275 because that's how wide we made the questlog button prefab, and it'll look best if those match. Then we can add whatever styling we want. I'm just going to make the color a bit darker, and under the scroll rect section, we'll uncheck horizontal, change the movement type to unrestricted, and uncheck inertia. And one more thing we need to do is click on the content game object underneath viewport, and we'll click add component and add a vertical layout group. This vertical layout group is going to be what makes the buttons automatically stack on top of each other, and for this example, we're going to keep the spacing at 0, make the child alignment be the upper center, and we can uncheck child force expand for both width and height. Then in the scripts UI folder of the project, we'll create a new C# script called questlog scrolling list and then double click it to open it up. We need to do a couple of things here. First, we probably want a method to instantiate a questlog button for a specific quest, so we'll add a using statement for UnityEngine.events and then create a private method called instantiate questlog button that returns the questlog button that will get instantiated and takes in a quest object as well as a Unity action to pass along to the button as the select action. And to do this, we'll need a reference to where to instantiate this object, which is going to be as a child of the content game object under the scroll view that we'll call content parent. And we'll also need a reference to that questlog button prefab we made earlier as the thing to be instantiated. Then in that instantiate questlog button method, we'll first instantiate that prefab under the content parent game object, and then we'll use get component to get the questlog button component. And just for organizational reasons, we'll set the name of that game object to be the quest unique ID with underscore button appended at the end. And then of course, we'll call the initialize method, passing along the select action and display name for that button. And then finally, we'll return the instantiated button. Next, we're going to create a public way to add a button to this scrolling list from the questlog UI, and with that, we'll want to make sure that duplicate buttons for any given quest can't be added. So at the top, we'll create and initialize a dictionary that maps the string ID for a given quest to the corresponding questlog button. Then whenever we instantiate a button, we'll add that button to the map by the unique ID for that quest. And then we'll create a public method called createButton if not exists that returns a questlog button and takes in a quest and select action for that button. And in there, we'll create a questlog button and set it equal to null and then return that button at the bottom, where in the middle, we're going to attempt to set that to something. And for that, we'll check if the ID to button map doesn't contain the key for the quest info ID, and if it doesn't, we'll call that instantiate questlog button method we created earlier and set that to the questlog button to be returned. Else, if it's in the map, we'll just get that from the map and then return that instead of instantiating anything. And that gets us most of the way there, but next let's actually test this out to make sure things are working as expected so far. So just for right now, we'll create a start method, and in that start method, we'll do a for loop from 0 to 3, and in there, we'll create a new instance of a questinfo scriptable object called questinfo_test, and we'll need to give it an ID, but the questinfo scriptable object is currently set up with a private setter for the ID. So for right now, just so we can see this work, we're going to make that public and then we'll change it back later. Then back in that start method, we can change the ID of the scriptable object to something like test, and then we'll set the display name to test plus the for loop iteration number. And we'll also need to initialize the quest step prefabs to an empty array here, or else we'll get a null pointer exception later on. And finally, we'll create a new quest with that questinfo scriptable object, and then we'll call the createButton if not exists method, passing in that quest and a function that just prints out which button we have selected. And then we'll also want to select one of the buttons, which to access the button, we actually have to add that to the quest log button script real quick. So back in that script, we'll add a using statement for unityengine.ui, and then add a field for the button component with a public getter and private setter, which we'll then initialize in the initialize method using getComponent. And with that, back in the quest log scrolling list script, we can select the first button that gets created in our for loop with this logic here. Finally, with all of that in place, what we expect is that when the game starts up, it's going to attempt to create multiple quest log buttons. However, we should only see one since all of these have the same ID, and the create button if not exists method checks for that before creating the button. Back in Unity, we'll add the script we just created to the quest log scrolling list game object, and then for the content parent, we'll drag in the child game object under the viewport called content, and for the quest log button prefab, we'll drag in the quest log button prefab from the prefabs folder of the project that we created earlier. And with all of that set up, we'll enter play mode where we'll see a single button in the scrolling list as expected, as well as some logging showing that the button was selected, indicating that our select action was properly called. So with that working, let's go back into our quest log scrolling list script, and now instead of all of them having the same ID, we'll change the ID to include the iteration number so that all of them are unique, and hence we should expect it to create 3 buttons in the scroll view. And with that change, back in Unity, we'll hit play, and just as expected, we see 3 buttons stacked one on top of each other, and as we move between them using the arrow keys, we'll see the logging change depending on which button we have selected. Now, back in that start method, we'll change this to include enough buttons to overflow the scroll view, so something like 20, and with that change made, back in Unity, if we hit play, we'll see that they fill up the scroll view, but if we scroll all the way down to the bottom, it doesn't actually scroll to the new items. If we were using a mouse or touch input to click and drag, this would be a different story, but because we want to use arrow keys to do this, it unfortunately gets a little bit more involved. Basically, we'll need to handle the scrolling part manually. So back in the quest log scrolling list script, at the top we're going to add serialized field private variables for the scroll view rect transform and the content rect transform. And then in the instantiate quest log button method, we're going to add a line here to get the rect transform for the button that we're instantiating. And for the select action we're going to pass along, we'll expand this to its own function that first calls the passed in select action, but then also calls a method called update scrolling, which passes along the rect transform for that button. And then below that, we'll create that update scrolling method. So basically what we've just done here is that anytime a button gets selected, it's going to call this update scrolling method in addition to the select action. And in there, we have access to positional values for the selected button, the scroll view, and the content via the rect transform components. And with all of that information, we can do some math to calculate where to move the content game object to scroll to the appropriate position for the button that we have selected. So for this, we're going to create a variable called button y min and set that equal to the absolute value of the button's anchored position y, and a button y max variable that will set to the button y min plus the height of the button. Think of this like as we move down the list of buttons that have a height of 30, the first one will always start at an anchored position of 0, the second an anchored position of -30, and so on. But instead of taking these negative values, we're taking the absolute values, which turns all of these numbers positive, which is a bit of a preference as you could leave these negative and the math that follows will just be a bit different. But in the end, these two variables are really just keeping track of the top and bottom positions of each button within the content game object. Then we'll calculate 2 other variables, one for the content y min, which will be the content game object's anchored position y, and one for the content y max, which will be the minimum plus the height of the scroll view. So for these variables, think of it like the content panel that contains all of the buttons will be extending beyond what we can see in the scroll view. The content y min variable is the current anchored position of the content game object, so for example, when we start out and it's at the top, it will be 0, and the content y max variable is that plus the height of the scroll view, which gives us the area with the visible buttons. So what we want to do with all of these variables is that when a button is selected outside of the visible area, we want to shift the content game object to show that selected button. So back in the script, when scrolling down past the viewable area, which can be indicated when the button y max is greater than the content y max, we'll set the content rect transform's anchored position to a new vector 2 that maintains the same x value, but the y value will be the button y max minus the scroll view's height. Otherwise, when scrolling up and out of view, which can be indicated when the button y min is less than the content y min value, we'll set the content rect transform's anchored position y value to the button y min value. And back in Unity, we'll drag in the scroll rect transform and the content rect transform into their appropriate slots. And one last thing, to make this work correctly with the math we did, we need to make sure that the button prefab has a pivot that looks exactly like this, with a 1 for the y value so that the origin position is at the top of the button. And after that, we can hit play to try try this out. And we'll see that if we scroll down past the viewable area, the content moves to align with the newly selected button as if it's scrolling down, and we'll see a similar behavior if we go back up as well. And one last thing I imagine most people might want is actually enabling the vertical scroll bar when the content overflows to show that there are more buttons downward. This is actually pretty easy to do. First we'll go to the vertical scroll bar in the inspector and then change some of the styling to our liking. I'm just going to make the background color a bit darker and more transparent, and then we want the direction to be bottom to top, and we can change this size field here to see what it looks like with the background color change. But just to note, the size field will auto update with the next thing we're going to do, so it isn't necessary to change this at all. And then on the content game object, we're going to add a new component called content size fitter and then set vertical fit to preferred size. And now if we hit play, we'll see the vertical scroll bar enabled and fully functional. And that pretty much does it for the scrolling list. And so back in the quest log scrolling list script, I'm going to comment out this test code in the start method that we added, but you could remove this entirely if you wanted. And of course, we'll also change that setter back to be private in the scriptable object. Finally, now that this quest log scrolling list is fully functional, we'll actually put together the rest of the quest log. In the scene hierarchy, we'll create a new game object called quest log UI, and then underneath that we'll create another new game object called content parent, which is going to hold all of the content for the quest log so that we can easily enable or disable everything by disabling this game object. And then underneath that, we'll right click and go to UI image to create a new image which we'll call backing panel. And we'll resize that to be however big we want the quest log to be. I'm going to go with a width of 800 and a height of 500. Then we'll also change the color to be black and a bit transparent, and then we'll make the quest log scrolling list a child of the content parent and position it over here to the left. After that, we'll right click and go to UI text mesh pro to create a new text mesh pro object which we'll call quest log title. Then we'll position that at the top of the panel like so, and we'll change the text to say quest log, keep it at a font size of 36 and center the alignment. And next, just to keep organized, we'll create a new game object called quest info, and then under there create a new text mesh pro object called quest display name text, and we'll put some placeholder text here, give it a font size of 24, position it right around here and underline it. Then we'll just duplicate that object with Ctrl+D on Windows, call this one quest status text, add some placeholder text, remove the underline and position it here with a left alignment. Then we'll create a new game object under the content parent game object called rewards, and we're going to do the same thing here, creating 3 text mesh pro objects called rewards title, gold reward text, and experience reward text, and we'll position those like so down here. And last, we'll create another new game object under the content parent called requirements with another 3 text mesh pro game objects called requirements title, level requirements text, and quest prerequisite requirements text, and then we'll position those over here. And I'm just going to clean up the positioning a little bit, and that does it for the quest log UI. Of course, position these things wherever you'd like to, and as mentioned, the idea here is that we can disable or enable this content parent game object to hide or show the entire thing. Next, we'll want to populate this UI with some actual data from the game's quests. In the scripts UI folder of the project, we'll create a new script called quest log UI and then double click it to open it up. First, we'll add using statements to the top for unityengine.ui and tmpro, and then we'll want to get references to all of the UI elements that we want to change or control, those being the content parent game object, the scrolling list, the quest display name text, the quest status text, the gold rewards text, the experience rewards text, the level requirements text, and finally the quest requirements text. Then we'll create a private method called setQuestLogInfo that takes in a quest, and in there we'll use the quest that's being passed in to set everything in our UI. So first, the quest name will simply be set to quest.info.displayname, and for the quest status, we'll come back to this, but for now we'll leave a to-do comment. For the level requirements, we'll set the text to the string level followed by the quest's level requirement, and for the quest requirements, since this can be a list, we'll start this as the empty string and then loop through any quest prerequisites we might have, adding the display name for that quest prerequisite and then using \n to move the string to a new line for the next prerequisite. And then for gold rewards, we'll set that to the gold reward plus the word gold, and we'll do something similar for experience rewards. And it looks like there was a typo up here, so we'll change that to be rewards with an S instead of just reward to be consistent with the other variables. So this method can be used to set all of the information for the quest log UI, and what we want to do next is call this method when a button is selected in the scrolling list. So we'll create another private method called questStateChange that takes in a quest, and in there we'll call scrollingList.createButton if not exists, passing in the quest, and a function that'll call the setQuestLogInfo method that we just created. And just to note, as mentioned earlier in the video, since objects in C# are passed by reference, this quest will always refer to the one with the most up-to-date state whenever this callback function fires off. And so next, what we want to do is subscribe this method to the quest state change event, so that way we receive events when the game starts up and can initialize all of the quest buttons according to those. So we'll create onEnable and onDisable methods, and then subscribe and unsubscribe respectively to that event using the Game Events Manager. And one last thing before we go test this out, and that's that the event system needs to know what to select in our UI, which is going to be the first button in the scrolling list. So we'll add a private button called First Selected Button, and then in the quest state change event, we'll get the quest log button back when we create it. And if the first selected button hasn't yet been initialized, we'll know that's the top button, and so we'll set the first selected button to that. And for now, we'll also just select it here, but we'll eventually move the button selection somewhere else. And with all of that, we can go back into Unity and we'll add the quest log UI script to the quest log UI game object, and then we'll drag in all of the appropriate values from the quest log UI to these slots. And for right now, we'll just keep the content parent enabled and then hit play. And we'll see that when the game starts up, the scrolling list gets populated with the couple of quests that we have in the game, and we can also use arrow keys to move between those two quests, in which case the information in the quest log is changing according to the quest that we have selected. That shows we have a pretty good foundation for the quest log UI, and so next we'll want to toggle the quest log with the press of a button, as well as stop the player from moving when the quest log is showing. For the player, I already have events set up to enable or disable their movement, so we can use those. And as for the input for toggling the quest log, I already have a quest log toggle action set up in the input action asset using the Q key, and the player input component is calling a method in a custom input manager script, which essentially sends out an event through the Game Events Manager anytime the Q button is pressed. So with all of that already set up, all we need to do in the quest log UI script is subscribe to that quest log toggle pressed event in onEnable and unsubscribe in onDisable, and we'll do that to a method called quest log toggle pressed, which we'll create down here. And then we're just going to check if the content parent is active in the hierarchy, and if it is, we'll hide the UI, and if it isn't, we'll show the UI, and then we'll create those methods below where when we show the UI, it's as simple as setting the content parent to be active, and we'll also send out the event to disable the player's movement. And then when we hide the UI, we'll do the opposite, setting the content parent to be inactive and sending out the event to enable the player's movement. And one last thing, before we were selecting the button here, but now that we're toggling the quest log, we can remove that line, and instead we'll select that button if it's not null whenever we show the UI. And just to note, we do need to do this after the content parent has been set active, because otherwise the onSelect callback won't work properly. And when we hide the UI, we also need to deselect the button from the event system, so that way it reselects and fires that callback the next time the UI opens. And of course, to do that, we'll also need to add a using statement to the top for unityengine.eventSystems. And now back in Unity, we'll disable the content parent for the quest log by default, and then we can hit play to test this out. And sure enough, if I press the Q key, we'll see that the UI enables with the topmost button in the scroll view selected, and if I press the Q key again, it disables. And also, when the quest log UI is showing, the player's movement is now disabled, and we can use the arrow keys to navigate the UI without also moving the player. So next, what we're going to do is change the color of the quest log button text depending on that quest's current progress state. We can do this in a bunch of different ways, but since we're already subscribing to the quest state change event in the quest log UI, and we have access to the quest log button there, we're going to take advantage of that and set the state directly on the button anytime we receive a quest state change event. To do so, in the quest log button script, we'll create a new public method called setState that takes in a quest state, and in there we'll create a switch statement with each of the possible quest states and some warning logging if the incoming state doesn't match any of them. If we haven't met the requirements to start that quest, or we just haven't started it yet, we'll set the text color to red. If the quest is in progress or can be finished, we'll set the text color to yellow. And last, if the quest has been finished, we'll set the text color to green. And now back in the quest log UI, since we already have a reference to the quest log button from this create button if not exists method, we can simply update the progress state on that button down here to keep the color up to date. And if we go back into play mode to test this out, we'll see that each quest is red at the start of the game since we haven't started either of those quests. But if we start the collect coins quest here, now the quest shows as yellow in our quest log. And if we go and complete the quest now shows as green, just like we wanted. So at this point, most of the quest log UI is functional, but we still need to fill out this quest status area. We're going to do this in a rather specific way for this video, but hopefully this acts as a good foundation that you can change in whatever way you need to for your own game. In the existing quest management system that we already have the individual quest steps reporting their current state, which eventually gets stored with the corresponding quest object. So how we're going to do this is by adding on a status field to that information, which is just going to be a string that each individual quest step will manage, and then we can create a public method in the quest class that goes through each of those stored quest step status strings and then returns a full formatted status string for the quest based on that information. And then since the quest log UI already has access to the quest object, it'll be as simple as calling that method to get the full status to be displayed in our quest log. And so in the quest step state class, we'll add a string field for the quest step status. And then in the quest step class, we already have this change state method that we were using to pass along the updated state for each quest step. And so we can just add this status onto the change state method and then also add that when creating the quest step state here. And of course, that means we need to change all of our more specific quest step scripts to now report status in addition to their state whenever this change state method is called. And so we'll start with the collect coins quest step script, in which we'll add a start method and update state from there, since now that we're reporting status, we need to do this right when the game object first appears in the game, rather than wait for the first state update like we were doing before. And then we'll add a status string down here, which will just be a string showing the coins we've collected out of the total coins we need to collect, and then we'll pass that along using that change state method. And for the other quest step we have, which is this visit pillars quest step, we weren't changing the state at all previously because there wasn't any state that we needed to keep track of, but we do want to update the status for this type of quest step. So we'll add that in by adding a new field for which ordered pillar this is, and then we'll create a start method and update the status to what we want it to be when this quest step is first instantiated. And because there's no state to keep track of for this quest step, we can just use the empty string for that part. And last, we'll update the status down here when we finish the quest step to something slightly different, like so. And of course, back in Unity, we'll want to fill out that config value for any corresponding quest step prefabs for the visit pillars quest. And that'll get all of our quest steps reporting their status, but now we need to make sure we're actually storing that status within the corresponding quest object. And so in the quest script under the store quest step state method, we'll make sure to store the status right below where we're storing the state. And so with all of that, the quest object should always be up to date with the current status string for each quest step in that quest. So the last thing that we need to do is create an easy way to get a formatted version of all of the quest step status strings to display in our quest log UI. To do this, we'll create a public method in our quest class called getFullStatusText that returns a string. And in there, we'll create a string called fullStatus and start it as the empty string, and then return it at the bottom, where in the middle, we'll calculate what this string should be. First, if the state is in the requirements not met state, we'll set the full status to something like requirements are not yet met to start this quest. Else, if we're in the can start state, we'll set the status to this quest can be started. Else, we've at least started the quest, and in that case, we want to use the status strings for whatever quest steps the quest contains. And so we'll loop through any of the quest steps that have already been completed by looping up to the current quest step index. And for those, since they've already been completed, we'll append these tags to add a strike through for that line, followed by a new line. And if the current quest step exists, that is, we haven't finished the quest yet, we'll append that status string without a strike through. And last, if the quest is in a state where it can be turned in, we'll check for that and then add on a string that the quest is ready to be turned in. Else, if the quest has been finished, we'll add on a string that says the quest has been completed. And finally, back in the quest log UI script, we'll call that getFullStatusText method on the currently selected quest, and then set that to the quest status text to be displayed. And after all of that, back in Unity, we can hit the play button to try this out. For the collect coins quest, we'll see that we can start it, but we don't yet meet the requirements to start the visit pillars quest. That being the collect coins quest is a prerequisite, and so we can go and start the collect coins quest, which will see the status text changes to that string we put in the quest step with 0 out of 5 coins collected. And if we collect a couple of coins, we'll see that the status now shows 2 out of 5. And once we've collected all 5 coins, we'll see that the status now shows 5 out of 5 with a strike through and some text letting us know that we can turn in the quest. And once we've turned it in, the text changes to show that the quest has been completed. And of course, we can do the same thing for the visit pillars quest, and since there are 3 quest steps for this one, once we've completed each step, we'll see that it gets crossed off just like we'd expect. And that's it for this video. Thank you so much for watching. I know this video has been a long time coming since making the first video in this series, and I do have at least one more video planned for this series to add a dialogue system, but that said, it might be a while before that comes out. These long-form educational videos take a long time to put together, and on top of that, I've been really focused on hitting some self-imposed deadlines for my passion project, The Path of Ren, which, by the way, if you think looks interesting at all, it can be wishlisted on Steam right now, which definitely helps me out. But anyways, if you found this video to be useful, be sure to like it so that more people see it, and if you want to see more from me, be sure to subscribe as well. But most of all, best of luck with your own projects, and I hope this was helpful.